Welcome to part 3 of our stirrup pump tutorial. In part 2, we discovered when the pump was moving in a downward direction, and we did this by asking a simple question using the compare node. We compared the position Y to the previous position Y, and we discovered that it was necessary to convert the previous position from a vector value to a real value using the vector to reals node, which we call an adapter node. The next stage is to make the pointer of the pressure gauge rotate in a clockwise direction when the pump is moving in a downward direction, and allow the pointer to remain stationary when the pump is moving in an upward direction. So how do we go about this? Well, the first thing we need to do is bring in another new node. So we go to our menu, new node, Xpresso, logic, condition, and we have our condition node. If we have a look at the node, we can see on the left hand side here we've got a switch at the top followed by 2 inputs. We can add more inputs if we wish to, but there's no need as we only need the 2. The first thing we need to do is wire the compare node's output port to the condition switch port. And we've set that up. The result node is still here so that I can illustrate how the compare node actually works. So when the pump is moving in a downward direction, we get a number 1 which forces the switch to use the second input, which we will actually call input 1, and we'll call this one input 0. That's our downward condition taken care of. We generate a number 1 from the compare and force the condition to switch to input 1. And then when the pump is moving upwards, we generate a 0, which forces the condition to switch to input 0. So that's how we switch between our 2 conditions using this simple result here. The first condition that we need to set up is the one that will leave the pointer in its current position when the pump is moving upwards. So we'll grab our pointer, drag it into the Xpresso editor, make it a little bit bigger as per usual, and then we'll set it up with rotation B at the output stage. And as we've done before, we need to convert the rotation B from radians to degrees, so we'll just get our degree node here. There she is, and we'll put that over there. Now we know the degree node's initial state is fine for us, so we can plug straight into it from there, and then the output from the degree node can go into input 0. That's our first condition set up. Our second condition's a little bit more involved. The first thing we need are a couple of math nodes, so we'll get those from our menu over here, calculate math. And we have our first one. We'll just bring that over there because that's going to be our second node actually. We'll just copy this across, and this particular node needs to be a divide, so I'll come over to our functions here, and in the menu just scroll down and select divide. The next step is to connect the position Y of our pump into the math divide, into the top input there, and we're going to divide that by 1000. We're doing this because we only need the pointer to move in very small increments. So we've divided our position Y of our pump by 1000. We'll just move this add along here a little bit and do the same with the condition so that we don't get cluttered up with the wires. And then we need to add to our pointer's rotation B the result of our position Y from our pump having been divided. So now we're able to add a small amount to the rotation B of the pointer when our pump is moving in a downward direction. So now we can connect the output of our add to input 1 on the condition, and we know that when we move the pump down we get a 1. Our condition is using input 1. We're using our position Y divided by 1000 added to our pointer's rotation B. That's both conditions set. The final stage is to get our pointer again and drag it into the Xpresso editor and make it a little bit bigger. And we'll set it up at the input stage with rotation B. And to finish off, we just need one more degree node, so we'll copy this one over here, drag that across, and then we need this to be a degree to radians, so we'll set that up in here. And that'll get our pointer, when we connect it up, working in the correct way. So we'll drag our wires in and everything's connected. So with everything in place, if I come across to our pump and move it downwards, then sure enough, our pointer begins moving clockwise. And you can see that it definitely only moves when the pump is moving downwards. When we move it back up, the pointer stays exactly where it is. And there you have it, another little mission accomplished. If we look at the expression as a whole, it does appear to be quite complicated. But because I've broken it down into its component parts and fed it to you in bite-sized pieces, I'm hoping that that's helped you to realise that these are a lot more simple to set up than they at first appear. To reiterate, we do have 3 definite stages. We have a clamping stage here that restricts the up and down motion of the pump. We've asked a simple question by comparing two values. And finally, we have a condition which will allow us to choose between two states. We can either leave the pointer in its current position, or we can choose to rotate it clockwise in very small increments. It's really nowhere near as daunting as it looks once you get into this stuff. In actual fact, it's no different to any other language. The more you speak it, the more fluent you become. That concludes this 3-part series, and it's been great. We've got a nice little project here. I've had a lot of fun making all of this, and I really hope you've had a lot of fun too following it all through. But anyway, that brings us to the end of it all. I'll see you soon on the next tutorial.